Our indoor air is filled with pathogens that we can't see. We breathe them in, and once inside our lungs, they start to damage our bodies. Of course, the pathogen that most people are talking about right now is SARS-CoV-2, which is the virus that causes COVID-19. In addition to that virus, there are many more viruses that are transmitted in the air. Those include the measles, influenza, and the rhinovirus that causes the common cold. One of the things that all these viruses have in common is that they're smaller than 0.3 microns. This is the symbol for a micron. They're 25,400 microns in an inch, so because they're so very small, we need an electron microscope to see viruses. When talking about air purification, you often hear about 0.3 microns because HEPA filters are rated to capture 99.97% of particles larger than that size. Viruses and nanoparticles, which are particles that are smaller than 0.1 microns and are hazardous to our health, and VOCs, which are dangerous gases, need special systems in order to remove them from the air. Your best bet for removing virus-sized and smaller particles is a filter, like our C-HEPA filter, that is rated to remove 99.999% of particles down to 0.003 microns. To remove gases, including VOCs and odors, a high-capacity activated charcoal filter is needed. But to achieve real peace of mind, you can use a multimodal air purification system that combines a C-HEPA filter, a high-capacity activated charcoal filter, with a hydroxyl radical generating system. Hydroxyl radicals are called nature's detergent. They break down pathogens while they are still in the air. Hydroxyl radicals are generated naturally in the upper atmosphere. Their function is to get rid of pollutants when they reach the upper part of the troposphere, which is the part of the atmosphere that's closest to the Earth. A hydroxyl radical is one atom of oxygen and one atom of hydrogen. With just one more hydrogen atom, it becomes a water molecule, H2O. And it desperately wants to become a water molecule, so it steals hydrogen atoms from wherever it can. The easiest place for a hydroxyl radical to steal hydrogen atoms is from organics that are in the air. Although hydroxyl radicals are generated naturally in the upper atmosphere, there are techniques that we can use to artificially generate them at ground level. For example, the Titanium Pro unit generates hydroxyl radicals by exposing titanium dioxide to high-intensity UV light. Using this technique, we can generate hydroxyl radicals to destroy pathogens in our indoor air spaces. In addition to being able to inactivate viruses and bacteria, they can also neutralize allergens such as pollens and mold spores. Organics in the air, like viruses, bacteria, VOCs, pollens, and mold spores, are all made up of molecules that have lots of hydrogen atoms, linking the atoms in the molecule together. When a hydroxyl radical steals a hydrogen atom away from a molecule, it breaks the links from that hydrogen atom to other atoms and weakens the molecule. That makes it easier for other hydroxyl radicals to steal even more hydrogen atoms, breaking more links. When enough of those links break, the molecule unravels. Why is this important when dealing with viruses? The surface of our cells is covered with receptors that are doorways through which things that are necessary for the cell can be brought inside. But each of these doorways has a lock. If a molecule, such as an enzyme, has the right key, it will be pulled inside the cell. If it doesn't have the right key, it will be kept outside. Viruses have evolved to mimic keys to fool the receptor doorways into allowing the virus to come inside the cell. Once inside, the virus takes over the cell and uses the cell's resources to make more copies of itself, which is what we call an infection. The spikes of a virus are protein molecules. If the virus spike's protein molecule unravels, it changes shape. If the key is the wrong shape, it can't open the lock and the virus can't get in. And so, the virus can't infect us. In addition to inactivating viruses and bacteria, by unraveling molecules, hydroxyl radicals can destroy gases such as methane and other volatile organic compounds.